Hello everyone and welcome to the binomial distribution. Binomial distribution is a well-known distribution in a discrete case. So as you know, we have discrete and continuous distributions. Binomial distribution is an example of discrete distribution. So what is binomial distribution? A binomial distribution is a probability distribution that models the number of successes in a fixed number of independent trials where the trials has two possible outcomes, success and failure. For example, suppose you are taking a multiple choice exam and there are 10 questions in the exam, and those questions are independent, and probability of answering each question correctly is 1/3, or let's say we have, for each question you have 3 options, A, B, C, and one of them is the correct answer. So this means probability of success is 1/3. And then I ask you, what is the probability that you answer 7 questions correctly? Now, this is an example of binomial experiment. Why? Because if you look at the conditions of binomial distribution, number one, there is a fixed number of trials, right? So here I mentioned that there are 10 questions. There are 10 questions, so in this case, n equals 10. And probability, and for each question there is success and failure, right? So which means correct answer and non-correct answer. And probability of success is, let's say 1/3, because you have A, B, C, and there is only one correct answer. So in this case, probability of success, or we give it the letter P, is 1/3. And then I ask you, what is the probability that you answer, for example, 7 questions correctly, right? Now, there is a condition here that we have to check that those trials are independent, and we assume that those questions are independent. For example, question 2 is not related to question 1. Question 3 is not related to questions 1 and 2. This is the meaning of independent. Now, the goal of the binomial distribution is to find probability of k successes out of n. So n equals 10, and here I can find probability that you answer like none of the questions correctly, or 1 or 2, or any number less than or equal n. Okay, so k, so this is called k. K is from 0 to n. It could be 0, 1, 2, 3, 4 until n. All right, so this is an example of binomial distribution. And this experiment is called binomial experiments. So remember, we have those 4 conditions. In trials, the trials are independent. Probability of success is fixed. And for each trial, we have success or failure. All right? All right. So as I mentioned in this example, we have to find probability of answering 7 questions correctly. Now, to find this probability, there is a binomial distribution formula. The formula says probability x equals k equals n choose k. So this notation, n choose k, and this is the combination, which means the number of ways of selecting k out of n, k elements out of n elements. All right, so this is called combination. In some books they use the notation c and k, or it's written in this way, c and k, which means the combination or number of ways. And this is called the binomial coefficient. All right, so to find this probability, we have to use this formula. N choose k P, which is probability of success, in our example, P equals 1/3, right? Times 1 minus P, which means probability of failure, or the complement of P. So in this case, it's 2/3. 1 minus 1/3 is 2/3 power n minus k. All right? Now, this is the formula for finding probability x equals k. Now, for the next, we have more details about the binomial coefficient. So C and K is given by n factorial divided by k factorial times n minus k factorial. This is how we find the coefficient term or the combination term. N factorial is n times n minus 1 times n minus 2, keep going until 3 to 1, k factorial times n minus k factorial. For example, in 3 coin tosses, all right, so we have 3 coin tosses. Getting 2 heads can happen in 3 different ways, right? Because in this case we have 2 heads means head, head, tail, and it could be tail, head, head, and the third option is head, tail, head. This is a short one because n in this case equals 3 and k equals 2. It's easy to list all of them. Now, if you don't know the number of ways, so instead of listing them, you don't have to do that. You can just use this formula, which is 3, 2, the combination, which is 3 factorial divided by 2 factorial times 3 minus 2, which is 1 factorial. So 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1, and 1 factorial is 1. So the answer is 3. And those are the 3 arrangements, right? Now, again, because n is 3 and k equals 2, we can list all of them easily. However, if n, let's say n equals 20 and k equals 7, it will be a very hard job to list all of them. This is why we need a formula or a way to find the coefficient term, right? Which is the combination, right? The combination C and K. All right. So binomial distribution has so many real-world applications. As I mentioned, this is one example. You have exam and you want to see probability of specific number of correct answer. It also has some applications related to quality control. For example, counting the number of defective products in a batch. Survey questions like calculating how many people say yes to a survey questions, medical trials, games, military applications, and it has so many other real applications. All right, next, let's look at one example. Actually, this is the example that I mentioned, but with different numbers. A student guesses on each 8 multiple choice questions, each with 4 options. So you have A, B, C, D, and there is only one correct answer. And the question is, what is the probability that the student gets 2 questions correctly? So we have to find probability of k equals 2. All right, so now this is a binomial distribution example. Why? Because there are n questions, right? There are n questions, so n equals 8. And we assume that those questions are independent. And P, which is probability of success, equals 25% because there are 4 options and there is only one correct answer. So probability of success 1/4, or you can say 25%. Right? And then we have to find the probability of students gets 2 correct answers, so probability x equals 2. So this is k. So k equals 2. All right, so plug in the numbers in the binomial distribution formula. So the binomial distribution formula says nk p power k 1 minus p n minus k. Right? So n is 8 and k is 2. P is 25%. Power k, which is 2. 1 minus p means 75%. N minus k, 8 minus 2 is 6. All right, so let's calculate 8, choose 2, maybe here. It's 8 factorial divided by 2 factorial times 6 factorial. So there is a way to do that. So you can do 8 factorial. There is a trick here. 8 factorial is 8 times 7 times, I can say 6 factorial. So I can say it's times 6 times 5 times 4, but I stop here because there is 6 factorial in the numerator, right? So 2 factorial is 2 and 6 factorial is here. So in this case, they cancel out. So 8 times 7 divided by 2, the answer is 28. All right, so this guy here is 28 times, you can plug in the numbers and use your calculator. The answer should be about 31 or 0.311. So it's about 31.1%. So if you guess in the exam, then probability that you answer 2 questions correctly is about 31.1%. All right, so that's it. I hope everything is clear, and thanks for watching.